And this is question 11. So we have a graph below that shows the maximum kinetic energy of electrons. Remember, kinetic energy is EK is equal to 1 over 2 mv squared. The maximum kinetic energy of electrons emitted from the cathode of a photoelectric cell varies with the frequency of the incident radiation. Now, before I start with this, I know that it's talking about the photoelectric effect. Now, in your mind, this is what you must already think. We have a beam of light, right? It's got these photons that are actually moving through with a certain frequency. Remember, the light has to have a certain frequency to actually emit electrons from the metal surface. Every metal surface has its own work function, the minimum energy required to actually emit an electron. Now, it doesn't really help so that the frequency goes and then it emits an electron, but the electron just bounces off or bounces up and it doesn't have kinetic energy. When the wavelength actually strikes the metal surface, the electron needs to have enough kinetic energy so that it can start moving around. Remember, when electrons start moving, we can then generate current. But if you bounce the electron up and it only has enough energy to swim and then it comes back down, then the electrons are not really good for us, right? We want them to have energy to actually start moving, because when we have current, there's a lot that we can do with that current as people. So that's what you must already think of. Think about your work function, think about your threshold frequency, and then think about the maximum kinetic energy that each electron will then have, or photoelectron. Now they've given us a graph. Now remember, when you talk about graphs, the gradient and the area can all tell us something. So I have a graph here. I've got the maximum kinetic energy on the side. If they ever give you this, please remember it and do not forget to include it in your equation. I can see it both starts on 0, 0, and I've got the frequency that is also times 10 to the 14, and it's measured in hertz. So 11.1 says I must define the term work function. Now remember, guys, in physical sciences, if they ask you to define something or give the law of something or the principle or the phenomena, right, it means it cannot change. You cannot explain something in physics if they said define. Even though it's going along the right path, the examiner cannot give you the correct mark. If you are giving a definition, it needs to be something precise and accurate. Everyone's definitions need to look the same. If you are explaining something, you're explaining based on your understanding. A definition is something that's fixed, that's the same, and that will never change but remain the same. So let's define the term work function. That's the first one. That will be 11.1. Work function is the minimum. Remember, don't write slang minimum. Ooh, I spelled that wrong, Jen. It will kill me. That is the minimum energy. Minimum energy needed to remove. And most of the time, this will actually be a clue for you guys on what's next to come. I can't spell today. Electron from the surface of the metal. A metal. Now this is exactly what the examiner is looking for. They're looking for that definition. I think this was for 2 marks, so you already have 2 marks in the bag. The next one says we need to calculate. We must calculate the work function of the metal used as a cathode in the photocell. I can see I've got my frequency, I've got my maximum kinetic energy, and I need to find my work function. This one's actually pretty simple, because remember, we've got so many constants in physics that you can actually rely on them. Let's start with the formula first. Point 1, remember, work function is represented by WO. We can say H and FO. Remember, H is Planck's constant. You find that on your formula sheet. Planck's constant is 6.63 times 10 to the negative 34. And then the frequency that I am given is 4 times 10 to the 14. Put this on my calculator. Let's see what we get here. So we can calculate the threshold frequency, the work function. Ooh, let me just go here. So I'm going to have 6.63 times 10 to the negative 34. I always say you must put brackets around your numbers so that your calculator doesn't do BODMAS. 4 times 10 to the exponent 14. Take that down, and then you must get an answer. So you get 2.652, remember, to 2 decimal places, so it's going to be 5 times 10 to the negative 19. So I'm going to get 2.65 times 10 to the negative 19. The SI unit for my work function is then a capital J for joules. So if you can actually continue with this, I know we have time up now, but if you can continue with this, you can just use the same format. Go through your formula sheet, look at what you're given. My advice to you, always stick with the numbers that you're given, so you don't have to always calculate, use that number and come back. And always remember, round off only your final answer. As you keep rounding off, it makes your answer a little bit incorrect.